NASA's OSIRIS-REx spacecraft will embark on an extraordinary journey back to Earth, carrying a small but significant treasure from the asteroid Bennu. After spending over 6 years in space, OSIRIS-REx successfully completed its mission of studying Bennu, a carbon-rich asteroid believed to have formed at the dawn of our solar system, now with a precious sample of regolith on board. This spacecraft is set to make its triumphant return. The OSIRIS-REx spacecraft will return to Earth on September 24, 2023, in the Utah desert at approximately 6:55 p.m. local time, Mountain Daylight Time. But what exactly is OSIRIS-REx bringing back? Join us as we explore the remarkable implications of this mission, from uncovering the origins of life to enhancing our understanding of asteroid orbits and our own planet's security. Prepare to be amazed as we delve into the captivating journey of OSIRIS-REx, a mission for the sake of all humankind. OSIRIS-REx, a mission to the near-Earth asteroid Bennu, holds great significance in our quest to understand the cosmos. Initially named 1999 RQ-36, the asteroid was eventually named Bennu through a competition won by 9-year-old Michael Puccio, co-hosted by the Planetary Society, the University of Arizona, and the MIT Lincoln Laboratory. Bennu orbits the Sun every 1.2 years and comes closest to Earth's orbit every 6 years, approximately 300,000 kilometers, 186,000 miles away. After launching, OSIRIS-REx entered orbit around Bennu on December 31, 2018, embarking on a meticulous process of mapping the asteroid's surface in detail. Once the team back on Earth identified suitable sampling sites, the spacecraft made its first sampling attempt on October 20, 2020. However, scientists were taken by surprise at what they discovered on Bennu's surface. The surface of Bennu proved to be loosely packed and fragile, defying initial expectations. When the spacecraft made contact, it sank in about 2 feet deep, with the robotic arm encountering no resistance whatsoever. The fragility and ease with which the material broke apart astonished the researchers, emphasizing the delicate nature of the asteroid's surface. The upcoming sample that OSIRIS-REx will deliver to Earth is truly unique. While scientists have previously worked with samples from other celestial bodies, such as the precious lunar samples brought back by Apollo astronauts from the Moon, and routinely study meteorites, the material retrieved from Bennu presents a distinctive opportunity. Meteorites that fall to Earth have survived the traumatic process of re-entering the atmosphere, which significantly alters their composition. In contrast, the material from Bennu would not withstand this process. Hence, the OSIRIS-REx sample is anticipated to provide a fresh and unparalleled perspective, unlike anything available from meteorite collections on Earth. As the sample from Bennu hurtles towards Earth, it carries with it a microchip containing the names of 442,803 individuals collected by the Planetary Society for the mission. These names embarked on a journey to the asteroid Bennu, symbolizing the collective involvement of space enthusiasts worldwide. While one set of names will continue their voyage to the asteroid Apophis, a duplicate set will accompany the sample return container back to Earth. The OSIRIS-REx mission to Bennu not only expands our knowledge of the cosmos, but also ignites a sense of wonder and exploration. It represents a collaborative endeavor to uncover the mysteries of our universe and brings us closer to understanding our place within it. The unique sample retrieved from Bennu has the potential to unveil unprecedented insights into the formation of our solar system and the origins of life. What is it coming back with? The material contained within the sample container from Bennu remains a fascinating mystery for scientists. While the exact quantity is uncertain, researchers believe there is a substantial amount to work with. According to Loretta, an estimated 250 grams, roughly the mass of a baseball, is anticipated, surpassing the mission's initial goal of 59.5 grams. The prospect of having an abundance of samples is considered the best-case scenario, providing scientists with ample material for analysis and investigation. Nicole Lunning echoes this sentiment, emphasizing the excitement of having more samples than they know what to do with. Once the canister is opened, a meticulous examination of the samples will commence. The material will be carefully laid out on trays for thorough photo documentation and spectral imaging. This process will allow scientists to identify and analyze the variations present within the sample. enabling them to make informed selections for further scientific study. Portions of Bennu's samples will remain at Johnson Space Center for in-depth research. However, smaller samples will be hand-carried to laboratories around the world thanks to NASA's Participating Scientist program. This global distribution of samples ensures that a diverse range of scientists and researchers can contribute to the analysis and understanding of Bennu's composition and origins. Moreover, many of the samples will find their place in the vault at Johnson Space Center, where they will reside alongside NASA's treasured lunar sample. These perfectly preserved pieces of another world will be securely stored, awaiting future generations of scientists who will have the extraordinary opportunity to unseal and work with them. This long-term preservation ensures that these invaluable samples will continue to contribute to our understanding of the cosmos for years to come. The material from Bennu holds immense scientific potential. Its study will provide unprecedented insights into the formation of our solar system and the origins of life. As researchers meticulously examine and analyze the samples, they will unlock new knowledge about the composition, structure, and history of this ancient asteroid. Each discovery brings us closer to unraveling the mysteries of our universe and deepens our understanding of our place within it. Why did we need OSIRIS-REx? The OSIRIS-REx mission, despite the previous Hayabusa and Hayabusa, 2 missions to Itokawa and Ryugu respectively, is of great significance and has several compelling reasons behind its necessity. While some may argue that multiple missions to asteroids might seem redundant, the OSIRIS-REx 7-year endeavor is undoubtedly worthwhile. Here are some key reasons for the need to undertake the OSIRIS-REx mission. To begin with, the asteroids visited by the Hayabusa missions and OSIRIS-REx, including Itokawa, Ryugu, and Bennu, share similarities. All 3 are near Earth and classified as potentially hazardous rubble pile asteroids. Being near Earth and potentially hazardous implies that these asteroids have orbits that bring them close enough to Earth to be considered a threat. While thorough observations have shown that 2 out of the 3 asteroids are not on a collision course with Earth, Bennu still holds a slim chance of impacting our planet between 20,178 and 20,290, with a 1 in 1,800 probability. Therefore, understanding asteroids like Bennu is crucial, as it enhances our preparedness to deflect any potential threat if such an asteroid were to pose a danger. The rubble pile designation of these asteroids implies that they are not solid objects, but rather composed of chunks of rock held together by gravitational forces. Rubble pile asteroids are believed to form when the remnants of larger asteroids destroyed in collisions reassemble to create new asteroids without enough mass for gravitational cohesion. By studying rubble pile asteroids like Bennu, we can gain insights into the early stages of planetary formation. This knowledge is invaluable, as it allows us to better understand how planets, moons, and even asteroids begin from smaller collections of materials. However, the key distinction between Bennu and the targets of JAXA's missions is its presumed ancient nature. Itokawa is estimated to have formed from a collision between asteroids approximately 1.5 billion years ago, while Ryugu's surface is thought to be about 9 million years old. In contrast, Bennu is believed to have originated within the first 10 million years of the solar system's history, and has remained largely unchanged for over 4.5 billion years. This makes the material collected by OSIRIS-REx akin to a time capsule, preserving the conditions of the early solar system and consequently the early Earth. By studying the samples retrieved from Bennu, scientists anticipate finding molecules that were present during the formation of life on Earth. These findings could provide vital clues about the origins of life, potentially revolutionizing our understanding of how life emerged on our planet. Thank you for joining us on this captivating journey as we explored the OSIRIS-REx mission and its remarkable return to Earth with samples from the asteroid Bennu, which hold the potential to unveil the secrets of our solar system's origins and shed light on the possibility of extraterrestrial life. Stay tuned for more updates, and let's continue to support the awe-inspiring achievements of space exploration as we push the boundaries of human knowledge and reach for the stars. We will definitely come with the latest updates of the spacecraft, which will return on September 24th, 2023, in the Utah desert at approximately 6:55 p.m. Till then, don't forget to subscribe to our channel for more fascinating content on scientific discoveries and cosmic adventures. If you found this video informative and captivating, be sure to like and share it with others who share a passion for space exploration.